Okay. Okay. Is my screen visible and am I audible? Nana Sekar, please confirm that whether I am audible or not. Let me check that whether it is recording or not. Yeah, it's recording. Yeah. Thank you. Thank you, Raja. Okay, I will just wait for few minutes, 1 or 2 minutes, and after that I will start today's session. And sorry, I was 1 or 2 minutes late today. I had some work to do. So anyway. Okay, 10 people are already joined. So let's just start actually because I have a lot of questions. So yeah. So we will do uh, at first at a stretch 1 hour problem solving session, and after that we will take a few minutes break, 4 to 5 minutes, and after that we complete the session. Okay, so as you most of you know that I am Dibyendu. I am a primary research fellow at IIT Kanpur, and I'm doing my research in soft and active matter physics, and I am doing this live problem solving sessions for the completion of this uh, thermal physics course, which Professor Debamalya Banerjee is the instructor of that course. So this is so that you guys uh, can get some exposure to how to solve these problems, and into so that you can do fairly well in the assignments and at the end of the day in the certification course. Okay, let me start the first question. So okay, let's just keep it interactive because I I want you guys to to participate in this more, so that the it will be good for you. Okay, so the first question says kinetic theory of gases assumes that the collisions between the molecule are perfectly elastic, perfectly inelastic, no comment, partly elastic. So can any yeah, so you can raise your hands in the this thing, and you can unmute yourself and answer that. Please answer it. You guys know it is very simple, right? Let me take the name. Raja, Nana, Jaga, anyone of you? Don't be shy, just unmute yourself if you know, or let's take a guess. Manirasi, I hope that I am doing the correct pronunciations. If not, then I'm I'm really very sorry. Please. So, Raja Shekhar, Raja, you can unmute yourself and you can talk to me or you can talk to your friends, like so that we can interact. Raja, why it is inelastic, not elastic?
Hello, sir.
Yeah, thank you for unmuting yourself. Yeah, I'm just please tell me the reason. And
Because of molecules are moving in random
okay, so but
with different drift velocities.
that's true. That exactly true.
Based on that concept, I think I mentioned here inelastic because of the particles. Each particle have its own velocity with the different directions.
Okay, but isn't it true that the velocity distributions depends on the number of collisions it does with the surroundings? So and also like mm, the main distribution factor there is main factor is temperature, right?
Yes, 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 sir.
Yes. So, but I will just I will give you the credit for attempting it, and that's great. I want rest of you to participate in this because that will be very much helpful for all of you, so that every conversations will bring some new questions. Okay, let me just let me just give me the let me just okay, answer it. Okay, so in kinetic theory of gases, is there any dissipations in any of the laws or in the postulates? There is no dissipation, right? There is no dissipation, right? So if there is no dissipation, so there all the collisions should be elastic, right? Because in inelastic collisions, some of the energy actually dissipates, right? So, but if you read about the main postulates of the kinetic theory of gases, there in the beginning it has been assumed that in kinetic theory of gases all the collisions between the gas molecules are perfectly elastic. So here that will be elastic because there is no dissipations. Everything is just uh, transferable. So that's why this is okay. Yeah. So that's why it is perfectly elastic. Okay. So now this problem, this is very easy, right? This is +2 level. Let's say you have two glasses of 500 ml water. The temperature of one glasses is 350 Kelvin and the temperature of other glass water is 330 Kelvin. Now you mix the water. What would be the final temperature? It's very easy, right? Please answer this. Feel free to answer it. Just unmute yourself and attempt it. Okay, let me just give some hints. Okay, so let's say the final temperature, let's say the final temperature is T. Okay, let's TF. Now if there is hotter if there is one glass which is of higher temperature, then if we mix with lesser temperature, then some heat will flow from hot to cold, right? Is it clear? So heat will flow from hotter temperature to lower temp, right? Then here 350, between 350 and 330 Kelvin, 350 is higher, so there will be some temperature, there will be some heat flow to this. Now del H in this system, the heat loss from this 350K water glass, what would be that? That would be, let's say C is the specific heat, mass M is the of the water. Okay, now that would be T, okay, minus TF. T is T higher, and that this heat released from this will be transferred to here, to the that will be gained by this glass water, right? So that will be C M T minus how much? TF minus T, right? Isn't it correct? So if you just do this, there is same amount of mass. So let's say it is H prime is double prime. So then del H prime and del H double prime are equal. You just cancel out. Then TH minus TF is TF minus T, let's say like low, T low, and if you just move it around, 2TF is TH plus TL, then TF will be 350 plus 330 by 2, that would be 340 Kelvin. Okay, so it's very easy. 40 Kelvin. Very simple problem. Okay, now here the question says the formula for average velocity, here for velocity let's consider it speed. If it is velocity, then there will be sign, okay, means like positive or negative. So average velocity will be 0, right, if this is velocity. But if we are talking about only the speed, the magnitude, then it will not be 0, right? It will be some of finite value, right? Now Do you know how to calculate it? Any anyone? Do you know how to calculate it? If not, then please say no. That then I will calculate it, or otherwise I will just say the formula, right? Raja, am I audible? Because I'm not getting any response. Kirtiga, Jagajiban, Manirasi, any one of you, please. Let me see the chat box. Okay, let me just. Any one of you, please. Just say that whether you know or you don't know. Then I will just, I will do that calculation. Siva Lakshmi, Murugan, Perumal. Okay. Do you know? Do you know how to calculate it, or I'll, yeah, yeah. Siva Lakshmi, you can talk. Okay. Let me just. Okay. So, so the velocity distribution, this function, this rho v, I will write it in terms of v, but you can write with any other symbol. So this is actually 4 pi v square divided by m by 2 pi kbt 3 by 2 e to the power minus mv square by 2 kbt. Let me see whether I have written it correctly. Yeah. Okay. Now, if you have to take the average and you are given the density function, then what is the for how do you do that? This is variable v. You need to take the average. So you just do v, the quantity you want to take, the average here, the average of velocity, just v, and then the distribution rho v, and you have to integrate over dv. Now when you are trying to calculate the velocity, then the integrate for velocity, then this limit should be minus infinity to infinity. So this is v rho v dv, and this is minus infinity to infinity, there is v cube term. Yeah, Jagajiban, please say, unmute yourself.
Sir, option B.
Yeah, that's definitely true, but I just want to know that you guys know the way to calculate the, the proper way to calculate all these things. I just that's why I asked it that whether you know or you don't know. Then I should show the calculations. But you are absolutely correct that that is root over 8 RT by pi m. But that is for speed. For velocity, it is 0, right? Because there is, if the distributions, if you take the Maxwell-Boltzmann distribution of velocity, then it is centered around 0, right? And if you take the this thing for the peak, that is also, if you take the average, that will give you 0. You can get it from here also. Let's see here. So then this, so here I am calculating for velocity. Anyway, thank you for answering. So this will be v, and then in the rho v term there is one v square here. Is my
Thank you,
car,
sir.
yeah, is my cursor visible? This pen cursor visible? Hello, it's visible, right? So here, okay, let me go here. Okay, so here there is v, so we want to take this v here. In the rho v term there is one v square, so this v square and v, that will give me v cube, and there will be e to the power minus this thing, okay, this constant thing. Now now, so this will give me some constant a, let me take this constant as a, times e to the power minus m v square 2 kbt. Now this is a Gaussian integral, and where the variable has odd power, and that actually gives you 0. So if there is odd thing and the integrand is, the limit is from minus infinity to infinity, that actually eventually gives you 0. But if you want to calculate, so for velocity it will be 0. So here I am just explicitly write it velocity and then speed. So for velocity this is 0, but for speed, which is mod of this thing, yeah. So for speed, this is, then this, the only change will be here, the limit will not be minus infinity to infinity, it will be from 0 to infinity. So that will be v rho v dv is equal to minus 0 0 to infinity v cube a term e to the power minus m v square 2 kbt by dv. What is in this a term? In this a term there is 4 pi times m by 2 pi kbt by 3 by 2. Okay. Now here 0 to infinity e to the v cube e to the power minus, let's say, alpha v square dv. Here alpha is m by 2 kbt. Now if you have attended the previous class, week 1 class, then I have written one integral 0 to infinity x to the power n e to the power minus alpha x square dx. This eventually gives you half times alpha minus n plus 1 divided by 2 into gamma of n plus 1 by 2. What is gamma function? This gamma n plus 1 by 2 is equal to n, what is that? So let's write it in terms of different way. Let's write it n plus 1, that will be n factorial. Okay. Now here n is 3, alpha is here, so what will be the value? 4 pi times m by 2 pi kbt 3 by 2 half. Here n is 3, so that will be 3 plus 1 divided by 2. So this will be, okay, this will be like this. So 3 plus 1 divided by 2, that will give me minus 2. So this is m by 2 kbt divided by minus 2. Here 3 plus 1 divided by 2, so gamma of 2 gives you 1 factorial, that will give you 1. Now this is here, let me just one page, let me just add one page. Let me add one page. Okay. Okay, so just so far it is clear. So now I have to just now I have to play with this constant. So here let's just carefully notice this thing. Here m by 2 kbt, here m by 2 kbt, there is 3 by 2, there is minus 2. So they will give you m by 2 kbt minus half. There is 1 pi, there is 1 pi, there is 1 pi, that will cancel out. There will be 1 4, this will, so let me write here. So first m by 2 kbt, there will be 3 by 2 minus 2, that will be minus half. Okay, let me write it here. So m by 2 kbt 3 by 2 minus 2, okay, times there is one 4 pi and 1 half, and in between here there is 1 pi, so that 1 pi will be 1 pi to the power 3 by 2. People are joining actually in between, so that's why I have to changes this thing. So can you follow this thing? Can you follow it? You can follow it, right?
Yes.
Yeah, yeah. So now, so this is 1 pi, so 1 pi will cancel out, there will be 1 root pi and 2. So if you just write it here, m by 2 kbt times minus half 1 2 divided by root pi. So if you absorb it here, it will give you kbt 8 kbt. So this will go here if it is minus half. So but in square form, so 4 times 2, that will be 8 kbt divided by pi m to the power minus half. Sorry. This will be like this, right? Is it clear? Every one of you? Any questions so far? So it is very crucial. Yeah. Someone wants to say something? Perumal?
No, sir.
Yeah. So the main catch of doing some problem is, if you know the distribution function very well, then you can do any kind of integral. You can calculate RMS, you can calculate any moment of velocity. Let's say you are, so in the previous week there was one question where you were to calculate the average of V cube. So in that way you can calculate any one of you just need to know the formula, and you need to know the distribution function. What is the distribution function? Distribution function is some standard form. If you remember it, or if you just, there is a good way to remember it. So you can ignore the constant, you can write it as A, and here the distribution actually varies as V square, and it falls exponentially e to the power minus V square. And if you just keep it this thing, this alpha, and here A, and if you take two actually two main considerations, that first the average of the probability, the distribution function integral, what is the probability, that will be 1. So the integration of rho v dv, that will be 1 first of all. Then average of V square, that will actually give you the, from kinetic energy or any kind of equipartition theorem, that should give you the degrees of freedom times kbt. So from there you can calculate, or you can easily find this distribution function. Okay, so there is no need to remember, but I will say that if you want to fasten the this process, then you should remember in this way, then you can just calculate all these things. Okay, so let me just do this, and here for speed then, so average speed will be root over of 8 kbt by pi m. You can say Dibyendu, there is no option like this, but there is RT, right? What is the relation between R? So R is Avogadro number n into kb. Now you can write here, you can write like this, right? 8 RT. So then kb, there is only one Na right here, Na times m. What is the individual mass of the molecule or atom times Avogadro number? That is his molar mass, right? So 8 RT by pi by capital M, where M, capital M, is Na by small a. So R by M is equal to kb by small a. Okay. Okay. So let's just quickly answer these questions. I calculated the root mean square speed RMS of helium and krypton gases at temperature T. My calculation shows that the RMS for both gases is same. Is my calculation correct? Please unmute yourself and attempt these questions. Perumal?
Second option, sir.
Yeah?
Second option.
Why?
Uh,
Tell me na. Don't be shy, Whatever you are thinking, think out loud. There is no,
temperature is same, sir.
yeah. Temperature is same, right? But masses are different. right? Masses are different, right?
No, sir.
What? Let me just help you, okay? You please be there, okay? So what is the VRMS? VRMS is 8 sorry 3RT by M, right? Right? Now temperature is fixed, but VRMS also depends on mass, mass of the molecule, right? Mass of the gas, right?
Yes.
So that's why it is not sim. That's why you're absolutely correct. Yes, Jagajivan, please.
Option B is right answer, sir.
Yeah. That's why Perumal also. Thank you. That's why also Perumal also answered. So you are absolutely right, and Perumal, you also absolutely right. So there is two dependency. First, VRMS depends on root over of T, and VRMS also depends on mass. You can think like that. If if the temperature is fast, they are jittering. The jittery motion actually happens very fast, right? It's very fast motion corresponds to the temperature, higher temperature. And if the mass is higher, it will have some inertia. It cannot move as fast as the lighter ones. Am I right?
Yes, sir.
Exactly. So you are absolutely right, as Jagajeevan is also right, that VRMS, despite of having same temperature, their VRMS is not same. So this option is correct. Okay. Now this one. The question says, what will be the pressure of two cylinders containing same number of helium and xenon gas at same temperature and volume? First option, read the options carefully. The pressure of helium cylinder will be more because helium is lighter than xenon. Both cylinder will have the same pressure. Pressure of xenon cylinder will be more because xenon is heavier than helium. None of the above. Please. Jagajevan, Perumal,
Third option, sir.
which option?
Third option.
Third option. Third option, right? You are saying third option.
Yes, sir.
So you are saying that pressure of xenon cylinder will be more because xenon is heavier than helium. Okay. Thank you for giving the answers. I'm very happy that you are participating in this conversation. Jagajivan, let me take another few answers. Murugan, Kirtiga, Raja.
Sir, I think option A.
So you are saying Renuka Devi, you are saying the
Option A.
option A, the pressure of helium cylinder will be more because helium is lighter than xenon. Okay, we'll see. But thank you for joining in the conversations. Thank you for that. I will take one more answer, then I will talk about it. Any one of you? Okay, let me answer. So here we will say this xenon and helium, they all behave like ideal gas, because I haven't said anything, so it will be like ideal gas. So what is the gas equation? PV is equal
PV
to,
is equal to nRT.
absolutely correct. PV is equal to nRT. N is the number of moles, which is same number of helium and xenon gas. R is a universal gas constant, which is a constant. T is the same. Volume is also same. Why should we expect pressure will be same? Pressure will not be same. So pressure should be same, right? V is same, N is same, R is same. R is same because it's a constant. T is same, so pressure will be same, right? Right?
Yes, sir.
Exactly. So
Means option B, sir.
yes, correct option is option B. Since so it depends on, so pressure then will depend on, it will be a function of N, T, V. Since everything is same, so this will be, so since everything is same, so pressure will also be same. Okay, just thank you. Okay, it's a very good problem. The most probable velocity of a gas with mass m at temperature T will be, Perumal, Murugan, Jagajiban, Kirtiga. Let me name few. Nana Sekar, you can unmute yourself. You can attempt like rest of our friends. Kokila, any one of you? Priya, Rajasekar, option B. Okay, great. Do you know how to solve it? Means the whole calculation, Rajasekar? Ramaswamy, any one of you except Raja?
Option B is correct.
Option B is correct.
I think, yeah.
Yeah, option B is correct. But do you know how to calculate it? Proper calculations.
Full derivation, I don't know, sir. But
Okay.
VRMS, EMP, that like that only.
Yeah.
Average velocity only. Final value only
Yeah,
I know,
because
sir.
you can absolutely neglect option C and option D, because they are,
Yeah,
the
sure.
dimension is not matching, right? So
Yes, sir.
option A and option B can be correct, but let me just, VRMS, we know that it is root over of 335 m, but let me just get the whole calculation. That will be beneficial for you, most of you guys. Okay, let me just do the whole calculation. So what is the distribution function? This is rho v 4 pi v square m by 2 pi kbt 3 by 2 e to the power minus m v square by 2 kbt. Now, any function, if you need to calculate the maxima, so most probable velocity is the velocity where the probability density is maxima. Okay, so this is rho v, this is v if you see this is like this. So let me, I'm a very bad drawing. I'm very bad at drawing. So this is a peak. This is the most probable velocity. We'll calculate PMP or V star. So at this velocity here the peak is there. So to calculate it, we have to take, you know, we will use only the this concept of getting the extremum value. So how do we find extremum value of a function? We take derivative with respect to the variable and we equate it with 0, right? Let's take the derivative here. You can also calculate along with me. So that will give, let me take all the constants except v, all the constants as a, okay. So let me take out a here, a, this is v square. So let me write in terms of this. So there will be v square and e to the power minus mv square together, because these are only varying, okay. So for v square, let me just reiterate once more, because so here a means this 4 pi and m by 2 pi kbt to the power 3 by 2 all are taken into account in a. So the rest of the things are v square and e to the power minus mv square by 2 kbt. So first I will differentiate with respect to v this thing, and later this thing, and I will equate to 0, because that is the way to find the extremum, right? What is the extremum? Can any one of you tell me what is extremum? So for v square this is 2v and this will be minus mv square. In between you can unmute yourself and answer that. What is the extremum? And for this one, this is v square. Please tell me. Right here. What is extremum? So then I have to differentiate with respect to this. This is 2mv by 2 kbt, right? That is 0. In a, because you can use it later, 4 pi divided by m by 2 pi kbt by 3 by 2. Okay. So this is a, this is v times mv square 2 kbt. Okay. And I can take out here, this will be 2, here v square, this is minus v, I have v and this taken care of. This is v square m divided by kbt equal to 0. So how many solutions are there? There are totally 3 solutions. First, v can be 0. So if v is 0, this is 0. One is v tends to infinity, if this is 0. Okay. Another option is to take from this one. So 2 minus mv square by kbt, let me write it kbt equal to 0. That give me, let's tell v star square 2 kbt by m. So v star is root over of 2 kbt by m. Is the answer correct? Do you, so I think who answered it? Probably I know the name, Savita Devi, right? Probably she's not here right now. So the answer is correct, 2 kbt by m. So 2 kbt by m, it's same as 2 RT by m, because we have previously said that kb by small m is of individual molecule or atom. This is by r by m. Now this can be this could be the answer, but if you get the double derivative, I have checked that. That would be a good homework. If you check with v equal to 0, v equal to v tends to infinity is unphysical, right? All of you agree? This is unphysical, right? All of you agree?
Yes, sir.
Okay. Now there could be two options: v equal to 0 and v this root over of 2rt by m. Why v equal to 0 is not possible? If you take the double derivative, then there to be a maxima, double derivative needs to be less than 0 if you put the value there. So if you, that could be a good homework. If you check, you can check that. You will take one derivative further, then there will be del 2 rho del v2, and if you put the value of v equal to 0 and v star value, if you will see that for v star value this is less than 0, so that's why it is a maxima. But I still didn't get any answer. What is extrema? Can any one of you answer it? Anyone? Jagajevan, Rajasekhar, Ramaswamy? Ramaswamy was answering pretty good other day. Then Moji, Tirisa, Tanishtha, Sivalakshmi, any one of you? Okay, so extremum is there's those could be minima, maxima, both of them. So extremum is something where del rho del v, for which value of v del rho del v is equal to 0. So they could be, so there the slopes are 0. So that could be minima, maxima, both of them, right? Okay. Okay, another good work question. I have a box filled with O2 gas at temperature T. My friend says that since the temperature is fixed, the velocity of each O2 gas molecule will be same. Is he right? That will test some concept. So please unmute yourself and have a go at it. Sorry, I just now is it visible, right? My screen?
Yes, sir.
Yeah. Please answer it, Renuka Devi. What do you think?
Sir, 1 second. A few minutes.
Okay. It may be wrong. Please try. No, there is no point in to be shy. Yeah, Perumal, please. Perumal? Yeah, tell me. What is your guess? Well, there should be some logical guess, right? because this is this means because of this. Okay, so please tell me, I have a box filled with O2 gas at temperature T. So now, so far we know the velocity, there is distribution, right? It is not sharp peaked. Do you know about Dirac delta function, which is like a sharp peaked? So these velocity distributions are not like Dirac delta functions, right? Perumal?
Sir.
So the,
First option.
yeah, that's great. Why is
Yeah.
so? Why is so?
O2.
Tell me na. So what I'm trying to say, have you got it right? That here, when we are talking about the velocity or speed, it has some distribution, right?
Sir, same temperature level, sir.
Yeah, but that there is in same temperature, right? But in the same temperature, the curve, so temperature is fixed means the average velocity is fixed, the RMS velocity is fixed, most probable velocity is fixed. Let me draw the curve. What is the velocity distribution curve? This is rho v, this is v, so this is like this, right? This is most
Yes,
probable
sir.
velocity, this is most probable. Here there will be some RMS like this. Now please tell me, is it like this? So if all the velocity are same, their distribution will not be like this. This distribution should be like this, right? At a fixed velocity, there will be a sharp peak line. This is called Dirac delta function, like sharp peak line. So have you ever seen this kind of distribution, velocity distribution? Please tell me, have you ever seen this kind of sharp peaked distribution, or you have seen this kind of distribution? Tell me, which kind of distribution you have seen, this kind of or this kind of?
Sir,
Which one?
the first one.
First one, right? So there is a broader distribution, so the velocity values are not fixed. They can, so average velocity is like this or like this, but one of the molecule can have larger velocity, one of the molecule can have lesser velocity. That depends on the collisions, right? So that their collisions are probabilistic. Hence, the velocity or speed, then the speed will have some distribution. Then tell me, there will be no sharp peak like this. So he is not right. Here he said that all will be same. He is not right. So he is not right. There will be some distribution. It has some broad broad structure. Okay. So in this way we can say this. Now tell me, if we somehow stop all the collisions between gas particles, will we still observe the velocity distributions? Tell me. This is easy, right? This is easy, right? Please raise your hand if you try to attempt it. If we somehow stop all the collisions between gas particles, will we still observe the velocity distribution? Why, Raja? Why so, Raja? Tell me. What is the main factor between this, velocity and all these things? Only one thing, right? That is collisions. Collisions are the main contributing, main means only factor, only contributing factor for velocity distribution. And how frequently collisions will happen, that depends on temperature, right? Because if they are very much hot, they will randomly move each, at each directions, and they will try to collide with each other, and they will then transfer the energy. Now you have just stopped the collisions. That means that is actually you can do when t equal to 0. There is no temperature associated to the system, so there will be no velocity distribution. So this will be no. Okay, is that concept clear? That velocity distribution depends, the main factor is T, temperature, because that will actually induce all the collisions. Okay, got my point? Okay, so this is a root mean square velocity of a gas with mass m at temperature T will be. This you can do, right? So I have given you the velocity distribution function, I have given you the formalism. Can you please try with your own hand to get the calculations? I will solve it later, but can you please try? Because what you have to do, I will give some hints. It is similar as this one. You have to just put in, instead of v, you have to put v square, and that will be here. That will be. Let me just put the pointer option. Let me just someone joined. Yeah. So here we have taken the average of velocity, speed or velocity. This is v, but their root mean square. So we have to take the mean of square. So we have to take the average of v square, and then after that we have to take the root. So can you attempt? I am writing the this thing formula. Please attempt it, and then I will solve it. Okay. I've just written. I'll write it here. There, this is rho v. This is to we have to calculate this thing. So this is 0 to infinity V square rho V dV. And what will be Vrms? Vrms will be root over of root mean square root mean square velocity. Please solve it. Please calculate it. Meanwhile, I will just take few minutes break. Please solve it. Okay. Okay. Please solve it. I am coming in 5 minutes.
Mr. Perumal, please solve it. Perumal. Hello, Perumal.
நோர வச்சிருக்க கம்முனேறா.
Hey, Gopal, first option answer. But அது எப்படி சால்வ் பண்றது?
அது ஃபார்ம்ல போட்டு பார்த்தேன்.
ஆன்சர் வந்து ஃபர்ஸ்ட் ஆப்ஷன். நீ கொஞ்ச நேரம்
கிளியரன்ஸா தெரிய மாட்டேதுடா டேய் ஆப்ஷன்.
ஆப்ஷன் வந்து 3RT divided by m root 3RT divided by m. பட் அது சால்வ்
ஆன்சர் எப்படி தெரியும்?
அவனே சும்மா சொல்லி விடுறான்டா.
இருக்கு அது இல்லடா.
அதான்டா.
Option A answer is correct, but derivation will be tough.
The derivation we don't Practical.
சொல்றா.
Please derive the answer.
ஒன்னும் புரிய மாட்டேங்குது டேய்.
எனக்கு தமிழ்ல தான்டா
Because
சொல்லணும்.
brilliant student.
யாருடா?
You? Solve it. Right there. முடிச்சிட்டா?
டேய் ரங்கா.
அவர் வந்து கழுவிலே உள்ள போட்டார். தெரியல. இப்போ அவர் வந்து என்ன தெரியுமா சொல்ல போறாருன்னா ஒரு சிம்பிள் ப்ராப்ளம் கூட முடிக்கிறேன், நீங்க எதுல பிசிக்ஸ் படிக்கிறேன்னு கேட்கறாரு.
பெருமாள் ஆன்சர் கண்டுபிடிச்சிட்டியா?
தமிழ்ல சொன்னா பரவாயில்லடா.
ஆமா ஆமா ஒண்ணுமே புரிய மாட்டேங்குது. இங்கிலீஷ்லயே சொல்லிட்டு போறாரு.
ஓரளவுக்கு புரியுது.
பெருமாளா
ஆ,
கண்டுபிடிச்சிட்டியா?
இதுதாடி.
Yeah.
ரங்கா
Yeah, Saktivel. Sakti. Yeah. Have you solved it? Have you calculated it? What is the value is coming?
Option is A, sir.
Option
Root of 3.
option A.
A.
Yeah. So you have calculated it, right? Okay. Thank you a lot. Yeah. So let me solve it or calculate. So here, then this will be in the same fashion. I will take all the constant out. So this is 4 pi m by 2 pi kBt by 3 by 2. Here 0 to infinity v square to the power minus mv square by 2 kBt dv. Same formula. Let me write it again. X to the power n e to the power minus alpha x square dx, that becomes half times gamma of n plus 1 by 2 alpha to the power minus n plus 1 by 2. So that gives you alpha is m by 2 kBt here, 4 pi m by, this is very easy. If you remember this distribution function, any moment you can calculate. This is half, here this is square, right? So there will be one more square. So v square and v square, it will be v to the power 4. This will be 4, 4 plus 1. This will be 5 by 2 into alpha means m by 2 kBt, that will be minus 5 by 2, right? Is it okay? Now this is, there is, let me just calculate in a, so this is m by 2 kBt, m by 2 kBt, 3 by 2 minus 5 by 2, so there will be m by 2 kBt common. The only thing will left is m by 2 kBt to the power minus 1 and half,
by 1
yes,
minus 1.
yes. So that will become 4 pi into half times 1 by 2 pi 3 by 2. What is gamma 5 by 2? This is 3 by 2 half into gamma half. Gamma half means root pi. This is standard formula, and only thing remains here m by 2 kBt minus 1. So there is 1 pi, root pi means half, 1 pi means 1, 1 plus 1 by 2, that is 3 by 2. Here there is 1 by pi 3 by 2, that will cancel out, that will give me 4 half 3 by 4. This root pi and this 1 by pi 3 by 2 will cancel out, right? And here it will be 1 by, then 1 m by 2 kBt is cancelled out, so 4 half 3 by 4, and it will be m by 2 kBt minus 1. So 4 cancels out, 3 by 2, so 2 will comes here, 3 is there, so that will give me m by 3 kBt minus 1, that is 3 kBt by m, which can be written as 3 RT by capital M, and that is root over of average of v square. So what is Vrms? So Vrms will be root over of average of V square, that is root over of 3 RT by M. So is the calculation fine?
Yes, sir.
Okay. Okay, let me. So this is a bunch of problems. I will discuss further problems in the in this upcoming time. Okay, this is based on mean free path. So first problem says a beam of molecules is passed through a low pressure gas. The mean free path of the molecules in the gas is 5 times 10 to the power minus 4 meter. Find the fraction of molecules that do not undergo a collision while traversing the thickness this amount. So the this formula is probability of n, which can be written as n by n0. N0 is the number of molecules, n is the number of molecule which doesn't go through the collision, is e to the power x by lambda. Here lambda is the mean free path, x is the amount of distance which has been traversed without any collision. So here let me just change it to this. So here what is lambda? Lambda is 5 into 10 to the power minus 4 meter. Then what will be the x? 5 into 10 to the power minus 5 meter. So x by lambda will be 10 to the power minus 1. So what is the fraction of, this is probability means the fraction of molecules. So the fraction of molecule that do not undergo a collision. So can you say what is will be the answer? So e to the power 0.1, there will be minus 1, right? Right? Anyone who has solved it? So here this is pretty simple, right? This is coming out to be 0.90. Pretty simple problem. Option B is correct, right?
Yes, sir.
Yes. Okay, let me get to this problem. The second problem says in an assembly of 10,000 molecules, each moving with same velocity, that is the assumption, calculate the ratio of the number that would travel undeflected, means without any collision, even after traversing a distance equal to 0.5 and 1 times the mean free path. So this is the extension of the previous problem. So can you solve it? Just try it and tell me the answer. I will write the formula here. So n1 will be n0 e to the power minus x1 by lambda, lambda is mean path. N2 is equal to n0 e to the power minus x2 by lambda. We have to take the ratio of n1 divided by n2. So it's pretty simple. Please do the calculation and tell me. What is the answer coming? I'll wait for 1 or 2 minutes so that you can solve it. This 10,000 molecules, there is no need to put into the equations because that will cancel out. N0 will cancel out. You have to take just ratio of this thing. I want the answer. I have written all the formulas, everything. I want the answer. Perumal, are you calculating?
Yes, sir. Yes.
Yes, yes.
On it.
Yes, great. It is pretty simple calculations. Perumal. So it is given, right? So what is x1? X1 is given.
0.58.
So your answer is coming 0.58. So you are saying that
0.58.
so you are, yes. Let me see what is the answer. So for x1 distance is 0.5 times mean free path and x2 is 1 times this, and if you put it here then n1 by n2 will be n0 cancel out. Let me write it here. So x1 by lambda is 0.5, so minus 0.5, and x2 by lambda is minus 1, so this is minus 1, so this is minus 1, n0 cancel out, this will be e to the power minus 0.5 by e to the power minus 1. So according to you, this one, for my calculation, it's coming out to be 1.648. So here the answer is 1.65. So that one way to check whether your answer is correct. Now if you have to traverse a longer path, there is there will be less number of molecules or particles without any collisions, right? So this this N1 will be lesser when x1 is larger. Now if you take this ratio, then that should be where N1, in the case of N1, it has to traverse less path. In case of N2, it has to traverse larger path. So their ratio must be greater than 1, right? So in that way you can, so let me write it, reiterate the thinking. So greater length to traverse without collision, N will decrease. That's why where N1 by N2 should be greater than 1 when x1 is less than x2, right? This is like simple concepts or simple logic. Okay, Perumal,
Yes.
did you get this answer?
Okay, sir.
Okay, the next problem. The problem says, if the molecular diameter of hydrogen is 1.9 angstrom, find the mean free path in nanometer of a hydrogen molecule in NTP using Maxwell expression. So what is Maxwell expression? So I have to calculate the mean free path. So what is the mean free path using Maxwell relations? Mean free path expression lambda is equal to 1 by root 2 pi sigma square n, where sigma is the atomic length or atomic or molecular radius, atomic or molecular, depending on the system, diameter, and n is the density, molecular density. Now here there is no, we do not know n, we know sigma, this is pi. So sigma is 1.9 Armstrong. Okay, but to calculate n, we have to take care of this thing. PV is equal to n kBt. N is the number of molecules. So n, sorry, this is the number of, this n is different. Let me write is the n prime. So n is n prime by v, that is p by kBt. Or we can use this expression directly. P is equal to this n kBt. So n is p by kBt. What is normal temperature and pressure? NTP, normal temperature pressure. What is P and T? Can anyone tell me? What is the normal temperature and pressure? So the normal pressure, how much? This is the 1 Pascal, right? This is the normal atmospheric pressure. And T, temperature, is 300 Kelvin. Now please calculate it and answer, tell me the answer. Now put it there. So then calculate first n, that will be P by kBt. kB
Answer B, sir.
330. You say
Yes.
You saying 330. Okay, let me check. Let me check the answer. So here your answer is coming out to be 256. Also, answer B 330, right? But for my case it is coming out to be, let me calculate this thing. So then if you put it here 101325, kb is 1.38 10 to the power minus 23. So 1.38 10 to the power minus 23 into temperature 3 into 10 to the power 2. If you put it here, it is coming out to be, for my calculation, according to my calculation, is 2.44 times 10 to the power 25. Okay, and then if you put it here, mean free path equation, that 1 by root 2 pi sigma is Armstrong. Armstrong means how much? 1.9. What is 1 Armstrong? 1.9 into 10 to the power minus
10 to the power of minus 10.
Yes, perfect. 1.9 into 10 to the power minus 10. Now n, this is 2.44 into 10 to the power 25. Now if you calculate it, this will be squared. Okay, now if you calculate it, for my case it's coming, let me check my calculations, is closer to 256 10 to the power minus 9 meter. So for my case it's coming 256. So you can check the calculations, where either yours calculations or mine, any one of this can be wrong, but the concepts are like this. Okay,
Okay.
okay,
Okay, okay.
yeah, okay. Let me proceed to the next problem. This problem says, for a hydrogen molecule with mean free path 361.5 nanometer, calculate the collision frequency at NTP. So I will give you the these expressions. What is the collision frequency formula? Collision frequency formula is AF, which is collision frequency, that is a ratio of average velocity divided by mean free path. Okay. Now what is the formula of average velocity or speed? So let me write it here. Average speed we have just calculated here, 8 kbt by pi m, and what is the lambda? Lambda is 1 by root 2 pi sigma square n, but lambda is given, we have to calculate this c only, right? To calculate this c bar, the average velocity, kb we know 1.38 10 to the power minus 23. So temperature T is 300 Kelvin at no, at normal temperature, and pressure is 1013.25 Newton per meter square. Then please calculate and tell me the answer. I have written all the formulas here. Please calculate and is it that difficult? Why is it taking so long? Let me help you to proceed further. What is C bar then? Then just calculate C bar first. C bar will be root over of 8 kBT, we know 1.38 into 10 to the power minus 23, and T is 3 into 10 to the power 2 pi, we know, right? M, what is the mass of hydrogen molecule? 2, right? And calculate it just. So there is no need of this pressure, okay? That is coming out to be, for my case, this is coming 1.78 10 to the power 3 meter per second. Then collision frequency F will be 1.78 10 to the power 3 divided by, what is the mean free path? 361. 361.5 times 10 to the power minus 9, which in my case is, after these calculations, is coming, this is 4.92 into 10 to the power 9. Okay, so this is the correct thing. Did you get it?
Yes, sir.
Any? Okay, very so far. Then this problem is very nice problem. Let me read it out loudly. The mean molecular diameter of air is 3 Armstrong. Okay, the molecular diameter is given 3 Armstrong, that's sigma. To what pressure in Pascal a vessel must be evacuated if its mean free path is 0.01 meter? The question then, so what pressure to be maintained after the evacuation, so that in that pressure the mean free path of that, in that vessel, whatever is left, is 0.01 meter. So we know that mean free path lambda is equal to root 2 pi sigma square n, and n can be calculated using kBT by p. We need to calculate p, so just we know lambda, so here put this thing, so this is root 2 pi sigma square, just write kBT by p and you will get it. So try to solve it. This is easy, right? And what is sigma? Sigma is 3 Armstrong, which will be 3 into 10 to the power minus 10 meter, and if you put that, this will be p by root 2 pi sigma square times kBT. So p will be lambda divided by root 2 pi sigma square kBT, right? Now put all the expressions there, and if you put all the expressions, it coming out to be, you can neglect this root pi also, but it coming out to be 1.33 into 10 to the power 1.33 Newton per meter square, and which is 1.33 Pascal. Okay, so if you do the calculation, it will come like this. Okay, let me proceed to the next problem. the question here says that calculate the RMS velocity of an oxygen molecule in an assembly at pressure 1.013 into 10 to the power 5 Pascal and temperature 300 Kelvin, having number density 5.4 into 10 to the power 24. So this is very much easy problem, right? Every problem is coming out from this, depending on these two formulas, which is collision frequency and all these things. Now here everything is not important. Here this C bar or this velocity average, which is root over of 8 kbt by pi m. But what is VRMS? So here we are to calculate VRMS, that is 3 kbt by m, right?
Yes.
Now how do we calculate this? So here oxygen molecule is given. So what is m for oxygen molecule? What is m for oxygen molecule? 32.
Oxygen, sir.
Yes. So now we just need to calculate this from this one. So if you put it here in this equations, this will be 3 times, for my case it's coming, just a minute. So this is 1.38 10 to the power minus 23, temperature is 3 into 10 to the power 2, and mass is 32. 32 is uh, for any number of molecules. So there will be 1 point, what is the average, this thing 6.023 10 to the power 23. This is the Avogadro number, and if you put it in the upper side, this 23 and this 23 is cancels out, so that will become 1.38 times 3 into 10 to the power 2 into 6.023 divided by 32. We can take into account here, so this will be 3 into 1.38, so this will be 9. 1.38 into 6.023 divided by 32 times 10. This is meter per second, sorry. So what is the calculations is coming out to be? Do the calculation and tell me. Meanwhile I will do it. What is the answer is coming? 9 times, it looks like I have to do the calculation. 6.023 divided by 32. Okay. What is your answer coming? For my case, it's coming. It's a root of 2 point something. So for my case, it's coming around 2.337 into 10 meter per second. So which looks like none of these options, right? So this will be the answer. Okay.
Sir, good evening, sir.
Yeah.
Sir, I have one doubt.
Yeah.
Previous class problem solving session, I think week 1, sir.
Yes.
Recording video not unable to open, sir.
Why? It is
In the
opening.
link.
It's opening.
In the link not open, sir. That's only I am asking.
So everyone is.
Any separate link is there, sir?
No, there is. So you guys are.
In the week 1 recording session also I will open it, but some error.
Why? I think it's working fine. Is any one of you? So everyone is. Each one of you facing same problem? Let me check. Let me check. Just a minute. Let me check.
1 second, separate link is there means you can chat with chat box, sir. I will copy it.
Yes. Please. Just a minute. That is a grave problem if it is not opening. Let me just. Oh, it's opening.
Yes, sir. I will check it my side, sir.
Yeah. Every one of you is facing same problems. You can paste the link in the message box. Then I can check.
Okay, sir.
Can you do that right now?
Wait, sir. I will.
Yeah, you do that. In one minute, I'm finishing this problem solving session. Okay. So now in the next problem, this is very easy problem, which says a container A is filled with a gas described by this. Another jar B is filled with the same gas with pressure 2p v by 4, something like ratio of number of molecules in jar A to jar B. This is very easy. Please tell me the solution. Please tell me the number, because this is very much easy. Very much easy. So what is this equation? Gas equations. PV is equal to NKBT. Right? Right. We have to
Yes, sir.
calculate this one. So N1 will be P1 V1 by KBT1, and N2 will be P2 V2 KBT2. So N1 by N2, if you take this, then it will be P1 V1 by T1. This will be T2 by P2 V2. So what is P1 V1? This is PVT. What is P2 V2? This will be 2P times V by 4, and T2 is 2T. And if you can take this thing, this will go there, and TT, this is half, so this is 4 by 1. So option B is right. All of you are facing the same problem? That I didn't know, that you guys are not able to check the videos. But that is very much important. So all of you are getting the same number, same ratio, 4/1. Please tell me. Please tell me.
Yes, sir.
Okay, that's great. Okay, just I have just one or two more problems. So now here, this is very easy problem. Please, I want this answer from you guys. A molecule has just suffered a collision. The average distance it travels before it suffers two successive collisions is option A 2 lambda, option B lambda by 2, option C lambda, option D none of the above. Please tell me. Please tell me what is the answer.
Sir, option B.
Which one? Option B. Lambda by 2. Why lambda by 2?
Sir, the average distance is suffered.
But average, why? Average is not like the mean. What is the average distance it travels before a collision? That is mean free path, right? What is the definition of mean free path? Mean free path is the distance a molecule traverses on an average without suffering a collision. Now you are saying that average distance it travels before it suffers two successive collisions. That will be 2 times of that, right?
Yes, sir.
Let me just clarify this. Okay. So what is mean free path? This is just definition, mere definition. Mean free path is the average distance traveled or traversed before one collision. That is lambda. So what is the average distance before two collisions then? That will be 2 lambda. So this is the option, correct option. Sorry. So this 2 lambda is the right option. 2 lambda. Okay. So last problem.
Okay.
Last problem today. Then we will call it an end. If in a closed container the collision frequency at temperature T is Z, what will be the final collision frequency if the temperature is increased to 40? Let me see. What is collision frequency F? This is C average divided by lambda. What is the lambda's expression? 1 by root 2 pi sigma square n. Is there any explicit dependence in the temperature here in this expression? Tell me. Is there any explicit T dependency here in this expression? In this expression, is there any? There is no T, right? There is no T. But in C bar, there is 8 kBT by pi m. So there is an explicit T dependency. So C bar varies as root 2. Then collision frequency A varies as root 2. So it is 40. So then it will be final, and this is initial. This will be root over of T final by T initial. This is 4T. This is T. This is 2. So this will be 2Z, right? Right?
Yes, sir.
Okay. Okay.
Okay, sir.
So thank you, and I will probably. Okay, so who was saying that there is problem in opening the videos in the YouTube link? All of you are checking the YouTube videos. Have you checked that link? That was working or not? No answer. But I didn't get the chat that link also for. So if not, then is she there or okay? So then so this is of this week 2 problem solving session. You will find these discussions there in the YouTube video link. I will update the Google Sheet, and thanks for joining in, and we will again meet on Monday next week. Okay.
Thank
So
you, sir.
Okay.
okay, thank
Thank
you.
you, sir.